Okay, so today is going to be review, chapter 7 review, and we are talking about triangle similarity. Triangle similarity, okay? Today is the 26th. Alright, so number one, write a ratio of the slope. So let's go back. Ratio is a fraction, right? Ratio is just a fraction. We know slope formula is y2 minus y1 over x2 minus x1. You know that. If you forgot it, there it is again, right? Remember that? Maybe. So every point's got an x and a y. x1, y1, x2, y2. We've done this formula. We did this formula in algebra. We've done it in here before. So let's just do it again one more time, okay? So then, it's got to be a fraction, right? Our answer's got to be a fraction. So I'm going to go, okay, y2, which is 0, minus y1, which is 5, over x2, which is negative 4, minus x1, which is negative 2. And the formula's actually up above the door, so if you forget, it's right above Jaden, up above the door. Okay, there's the slope formula, okay? So if I simplify this, I really get negative 5 over negative 6, which is 5 over 6. Now, I'm going to show you another way, okay? So let's say you don't like formulas, right? Some of you don't. You could always graph it, couldn't you? Because, okay, I would go, gosh, Mr. Davies, I do not like formulas. I would much prefer to see it visually. So 2, okay, and negative 4, 0. Let's check it out, right? Here's my line. I'm doing the exact same problem, but I'm doing a visual, okay? So I'd rise over run. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There it is, up 5 over 6. Another way to do it, right? Which way do you prefer? Doesn't matter to me. Whichever one gets you the right answer, okay? Is that helpful? Okay. All right, number 2. Given these triangles, determine if they're similar. So first of all, what I have is two sides, right? So again, let me put it on the side. There's three ways. We've got angle, angle, sim, or we're going to have a side, angle, side, sim, or we're going to have a side, 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 sim. Okay, now on number 1A, or excuse me, on number 2A, right off the bat, I'm thinking it's got to be probably that one, right? It's got to be that, probably that one. But let's show why. First of all, I do know that angle is congruent to that angle, right? Vertical angles, I know that. Now the next thing I've got to make sure is the ratios. I'm checking, I need to know that the ratios are going to be the same. Because if they're not the same, they're not similar. The ratios must be the same. So is 4 over 10 equal to 6 over 15? Is that true? See, 4 goes to 10 as 6 goes to 15. Is that true? Well, I'll reduce that to 2/5. Reduce that to, divide both by 3. And I get 2/5. So yes, so we're going to say yes by our side, angle, side, sim. How's that? And I've shown my work. The ratio is 2 over 5, okay? So tomorrow you're going to a similar question. I'm going to say, okay, are they similar by what? And then I'm going to ask you what the ratio is, okay? So the ratio in this case is 2 over 5. Am I going too fast or am I okay? Thumbs up? Sideways? Everybody good? I see three thumbs up and 1 sideways. Everybody else is just chilling, okay? So I'm going to take chilling as I'm okay. Right, Ben? Right. Okay, number 2. B. Well, first of all, I don't see anything about any sides. You guys agree? So it's got to be angle, angle, okay? But how can I prove it? How can I prove it? What do you see?
The Z.
You see the Z, which is my alternate angle. So that angle, it's got to be congruent to that angle, okay? And in this case, it doesn't really matter. You can use the vertical angles or you can just use the other Z, right? You probably prefer the vertical angles. So yeah, definitely by angle, angle, sim. Similarity, okay? All you need is 2 angles because the third angle is going to be forced to be equal, right? If 2 of them are, the third one will be, okay? C. Well, C kind of confuses me, so I see some triangles. Let me redraw my triangles. So I'm going to I'll show you what I'm going to do. For me, I get confused, right? I do. I get confused. So I'm going to, here's my blue triangle, and I'm going to take this other triangle, I'm going to redraw it. down here, just in the same orientation, okay? Some kids don't have to do this because some kids are smarter than me. I'm just going to draw it out like this. So this side here turns out to be 15. You okay with that? See the 15? That's why I like to redraw it, okay? This is 15. This 9 and this 12. I think the 9 would go here and the 12 would go here, right? If I redraw it, it's just kind of like flipping it up. So, slide it over real quick. It's not going to be angle. It's probably going to be side because we got all three sides, right? We just have to prove that the ratios are the same. So let's do that. So off the bat is, let's see, we'll go blue is 8 to 9 equal to 6 to 12, which is equal to 10 to 15. Are those all the same ratios? No. No. So are they similar? No. They're not similar, okay? Because the ratios did not turn out to be the same, okay? Yeah.
Wouldn't it be 6 to 9 to 12?
Do I need to flip this around, do you think?
Yeah.
Oh my goodness. Okay, so you want me to put the 12 here. So you're saying the 12 goes here and the 6 goes here?
Wouldn't it be an 8? Or 9?
8 go to 12. Oh my, that is a 9. You know what? Maybe I got it turned around. See what I do? Okay, you're saying that the 9 would go here and the 12 would go here, huh? So the 12 would go here. I might have made a mistake. It happens.
Yeah, that makes more sense.
Oh boy, these are hard to turn around sometimes, huh? Okay, now let's try it. Okay, maybe I'm wrong. 8 goes to 12. As we'll go 6 goes to 9, right? As 10 goes to 15. Oh, that might work, right? 2/3, 2/3, 2/3. Thanks, Keisha. It does work. Yes, by side similarity. Boy, I tell you, sometimes I get these all turned around. Glad to know I'm not the only one, huh? So I drew them the wrong way, didn't I? Okay, yes. Sorry about that. Thanks, Keisha. Are you guys good now if I didn't confuse you too bad? I just turned it around the wrong way. Okay, number 3. Well, they're parallel, so they have to be similar because you can prove the angles are equal and this angle here is equal. So the way I like to do this is I like to look at different triangles. So let's put it in. They're all 2.8, so BD, DF, and FG are all going to be 2.8. So we'll put my 2.8, my 2.8, and my 2.8 for BD, DE, and FG, even though it doesn't look like it because I'm not much of an artist. Okay, so find CD. Okay, that's this one here. And so the way to find CD is this. I would say that I'm going to go ahead and color it CD. Okay, do you see the blue triangle? You guys see the blue triangle? Of course you see the blue triangle, okay? And then do you see a little triangle, little orange triangle? So I'm going to go and look at the triangle. So CD goes to 3. CD goes to 3 as, okay, all of this whole side goes this side. So all of this is going to be a 2.8, 2.8, which is going to be 5.6. 5.6 goes to 2.8, right? So you see this side goes to this side. CD goes to 3 as this whole side, this entire side is 5.6, right? Goes to this, okay? So then it's twice as big. Can anybody see that's twice as big? And if you can't, let's do the math, okay? Let's multiply by 3, and CD would equal what is 5.6 times 3 divided by 2.8. Use your calculator, and I think you're going to get that to be 6, okay? But it had to be twice as big because I knew I had this and this, right? How am I doing, okay? Hopefully this is going to be an easy quiz for you, right? Okay, number 4. Find PR. So PR is right here, okay? PR PR. So PR. So do you see two triangles? I see a, let's go, I see a big blue triangle, right? And I see a little orange triangle, okay? So let's set it up. So if I want to find PR, PR is part of that, but I think if they're parallel, I can use that formula. I can go 10 goes to 6. I've got another form, 10, so I can say 10 goes to 6 as 12 goes to PR, as 12 goes to PR. 10 goes to 6, this side goes to this side, as this goes to this side, okay? Because they're parallel, we can use that theorem. So if I multiply up the PR, I'll have 10.
Mr. Davies, wouldn't it be 16 and instead of...
Well, if you want to use the entire triangle, you can. I'm just using, yes, that's another way to do it. Yes, absolutely. I'm not going to do it that way. I want to do side to side. And I can show that if you want. It's a little bit harder.
No, it's okay.
Okay. You're right, though, Katie. So I'm going to get 10 times PR equals 6 times 12 is 72. Divide by 10, and PR is going to be 7.2. So real quick, Katie, let me do it the other way, okay? Because it should work, right? So real quick on the board, if I went 10 goes to 16, right? As 12 goes to 12 plus, let's just call it X. Makes it easy, okay? How's that? Okay, we should get the same answer, shouldn't we? So we got this to the whole thing equals this to the whole thing, and that's going to be 12 plus X, you agree? Okay, so then I get my 10 times my 12 plus my X equals 16 times 12. 16 times 12 is 6 times. I don't know what that is. 16 times 12, I get 192. Okay, if I divide by 10, divide by 10, 12 plus X equals 19.2. Oh, I'm going to get a different answer, aren't I? No, I'm not. No, same answer, minus 12, minus 12. Has to be the same answer. It has to be. 7.2, there you go. Okay, has to be the same answer. And the only reason this works is we learned a theorem that said if it's parallel in a triangle, you can set it to the ratios of these pieces, okay? But I like the way you did it, because you said there's similar triangles. You said, okay, this side of this triangle to the whole side, and then you said this side of this triangle to the whole side. And both work. Isn't that snazzy? That does work. My goodness. It's a math world, you guys. It's a math world. Scary, huh, Ethan? But we need people who can write and create. Okay, how about this one? You guys remember this one? So if it's an angle bisector, we're going to have this side of the triangle goes to this piece down here equals this side of this triangle goes to this piece right here. So let's see, where am I going to squeeze all that work in up here? So I'm going to go 4a minus 2 over 2a equals 24 over 14.4. How am I doing? Okay, so this piece, the side of the triangle over it. Oh, that's no good. That's better, huh? So I'm going to go this side of the triangle over this piece goes this side of the triangle over this piece. So let me cross multiply that times that, that times that. So I'll have a 14.4 times my 4a minus 2 equals 2a, so that's a 48a. So 2a times 24, 48a. Okay, so I went 14.4 times my 4a minus 2 and my 2a times my 24. 2a times 24 is a 48a. And then if I distribute, I'm going to get, I don't know, it's 14.4 times 4. Let's find out real quick. 14.4 times 4 is a 57.6. So I get a 57.6a minus, it's going to be a 28.8 equals my 4a, right? 48a. Let's see, minus 57.6a minus 57.6a. That's what I get. Let's see, 48 minus 57.6. I get an answer about negative 9.6. So I've got a negative 28 equals a negative 9.6. A, right? How am I doing? Am I going too fast? It's a little sloppy, but hey, we'll make up for it. Divide, so negative 28 divided by negative 9.6. I get about a 2.91. Oh, that's a bad answer. Well, 2.9. Just round up to A. Okay, then we can plug them in, right? Put that there. Put that there. So 2 times that. So this is going to be about a 5.8. And this one's going to be 4 times that 2.9 minus 2. And I can answer about 9.6. Really?
You forgot to put the 28 on 28. Under your 28, but you forgot to put the 28.
Oh, that's where I ended up. Oh, thank you. I need more sleep, don't I? Too much track, not enough sleep. Thanks, David. 3. So it turns out to be 3. A is 3. Thanks, David. So let's plug in the 3. So that's 6. Plug in 3 is 12. Minus 2 is 10. Thank you, David. I did forget that. Yeah, we could all use a little bit more sleep. Thank you, David. That's 2 mistakes this morning, huh? Oh, my goodness. And I'll get home late tonight from OMAC. I'll be tired tomorrow. But look, you guys look just as tired as I am. Right? Is anybody awake? David's awake. Keish is awake. Anybody else awake? No. Nate, you're just barely hanging in there, aren't you?
I stayed up feeding.
I know. Okay, let's get these done, all right? Let's finish these up, okay? All right, so these are parallel lines. So we learned that you could say this piece over this piece equals this piece over this piece, okay? So we can just go straight to, I'll do it on the side because I'm running out of room. I'll go straight to FH over 7 equals 3 over 5, okay? Okay, so this over this equals this over this, okay? FH over 7. This piece over this piece equals this piece over this piece, okay? FH over 7 equals 3 over 5. Let me multiply by the 7, and I've got FH is equal to 21 over 5, or, what's that, 4.2?
Yes.
Yeah, 4.2. Okay. All these are is really setting up the little fractions, the ratios, and solving, right? Okay. That should say parallel.
Oh, we can't see it very well.
I know, let's scoot it over, okay? So find TS. All right, same thing. So we're going to say TS over 4 equals 18 over 5, right? So we'll just set it up as TS over 4 equals 18 over 5. This piece over this piece, because they're parallel, equals this piece over this piece, okay? Or Katie, we could do it the other way with 2 triangles, right? Both will work, okay? So multiply up the 4, and TS is equal to 4 times 18 over 5. I don't know what that is. 4 times 18 divided by 5. I get an 86.4. That's not right. Divided by 5. Oh, that's because I can't even divide. Okay, 4 times 18 divided by 5. 14.4. There you go. Okay. Alright, this one's easy, but a lot of kids miss this one, okay? But you guys aren't going to miss this one. Heck no, okay? So if they're similar, here's where I want to start. Let's start with the angles, okay? And you guys are not going to miss this tomorrow. So many kids miss this problem. It's not hard. 78, 78. Okay, I'm going to stop real quick, okay? 78, 78. Put that in there, okay? You agree? 78 degrees, 78 degrees, okay? Corresponding angles are congruent, okay? 40, 40. Vertical angles are congruent, right? Right? Now, if I want to find angle J, let's just go 180 degrees. We're going to go 180 minus my 78 plus my 40, right? Go 180 minus my 78 plus my 40. And I get an answer of 62. So if J is 62, so is M, okay? Don't blow this. Tomorrow's so easy. Corresponding angles are equal, right? Don't mess this up. You guys can do this, okay? So right off the bat, angle J, we got that one. Angle J is 62 degrees, right? Angle N is 78 degrees, right? So thumbs up on that one, right? Everybody agree? Thumbs up. Everybody can do that one, right? Just corresponding angles are congruent. And then we had to find that one from 108, okay? Now, to find the sides, we're going to have to set up proportions, okay? So, I know that, you guys watching? This side goes to this side as this side goes to this side. Say it again. This side goes to this side as this side goes to this side. Or this side goes this side as this side goes this side, okay? Either way, okay? So first let's find KL. So KL's here. So KL goes to 24, right? So go KL goes to 24 as, so I'm going little to big, so I gotta go little to big, so I gotta go little to big. 10, I can't do 10, but I can do my 8, 20, right? So I can go 8 goes to 20.
You can't see it.
Oh my gosh, Katie, sorry. Little to big, little to big. KL goes to 24 as 8 goes to 20, okay? Little to big, little to big. Okay, so then if I cross multiply, bring the 24 up there, I'll say that KL is equal to 24 times 8 divided by 20. I'm just going to use my calculator. And I'm going to go, okay, 24 times 8 divided by 20. And I get about 9.6. Okay, we're getting there, huh? LM, here's LM. So do LM. LM goes to 10 as 20 goes to 8, right? LM goes to 10 as 20 goes to 8. So I'm going to go big to little, big to little. So let's go LM goes to 10 as 20 goes to 8. Okay? And I'll just multiply up the 10 so that LM is equal to 200 divided by 8. I don't know. Is that 25?
Yeah.
It's got to be 25 because there's 8 quarters and $2, right? It's got to be 25. Okay? All right, can you do those? This should be easy tomorrow. And a lot of kids mess this up. You guys are not going to mess this up tomorrow, are you? Okay? You're not. You know opposite angles, corresponding angles are going to be equal, and then you just have to set the ratios, okay? All right, here's this one. We're going to do it one more time. Prove that they're going to be. So, if we go back to our warm-up, we're going to do this. Do what we did on our warm-up, okay? So let's do it. I'll do it with you, step by step. J, -1, 0. K, -3, 1, 2, 3. -4, 1, 2, 3, 4. There's K. L is at 3, 1, 2, 3. -2. There's L. M is at -4, 1, 2, 3, 4. And -6, 1, 2, 3, 4, 5, 6. And finally, N is at 5, 1, 2, 3, 4, 5. 1, 2, 3. Okay, let me draw in my triangles. And we're going to see 2 triangles in here, okay? We're going to see a little triangle inside a big triangle, okay? Okay, so first of all, let's take a look. I've got a red, let me do my little red triangle, right? And I'm going to do my bigger blue triangle on the outside, okay? So, easy. First, what's the easiest one to get? Easy. What's the easy piece in there that I can prove? Yeah, everybody agree? Angle J. Let's get the easy piece. Okay, right at that, angle J is the same angle to both triangles. Angle J is the same angle to both triangles, right? I mean, J is for both triangles. So right off the bat, angle J is congruent to angle J. Please state that, okay? It's a proof, right? But it's the kind of proofs I like, not the stupid little 2-column proofs, okay? Which nobody uses, by the way, okay? So then we know angle J is congruent to angle J, okay? We got that by reflexive property. But now the next thing we have to do is figure out these ratios. So I've got to come up with the angle, with the sides. So first of all, let's figure out what JK is. Let's figure out what J, what's this one, M? Is that M? Yeah. So let's find JK and let's find JM, okay? We can do that by Pythagoras theorem, okay? So let's check out this triangle, okay? So I'll highlight the triangle real quickly. Okay, you guys see this first triangle? It's right in here. 1, 2, 1, 2, 3, 4. So JK is going to be 2 squared plus 4 squared equals C squared, right? So I'm going to have a 4 plus 16 equals C squared, right? 2 squared plus 4 squared. 1, 2, 2 squared plus 4 squared. That's 20. So JK is going to be the square root of 20. Okay, I'm going to leave that right there. I'm going to come back to it, okay? Right? Square root of 20. Leave that. Now, what about JM? All right, JM. I'm going to get my eraser. Erase. Use my Pythagoras theorem again. Okay, now I got this triangle here. 1, 2, 3, 1, 2, 3, 4, 5, 6. So I'll go square root of 3 squared plus 6 squared, right? Square root of 9 plus 36, which is square root of 45. Okay, I'm going to leave that alone, come back to it, okay, right? So then, I got to find out something about these other sides. So let's find out something about JL. Find out something about JL. And let's find out something about J, must be N, right? It's got to be N. Let's find out something about JN. Okay, so JL, let's see. Again, I'm going to put my little right triangle in here. So here's my little right triangle right there and there. And it's going to be 1, 2, 1, 2, 3, 4. All right, so I've done that one. 2 squared plus 4 squared. I already know that one's going to be the square root of 20, okay? I just did that work, right? And then JN, let's see. JN's 1, 2, 3, 4, 5. 1, 2, 3, let's see, do it again. 1, 2, 3, 4, 5, 6. 1, 2, 3. So it's the same one as this one, square root of 3 squared plus 6 squared, but I already know that answer. That's square root of 45. So do they have the same ratios? Yeah, let's check it out. So now I can do my ratios, okay? So I should be able to say that the ratio of JM over JK hopefully equals the ratio of JN over JL, which is not going to be hard at all because they're the same numbers. So I got the square root of 45 over the square root of 20 equals the square root of 45 over the square root of 20. Let me stop for a second, let you catch up. Stop for a second, let you catch up, okay? No, those are either really ugly numbers or like Natalie learned, we could just use our calculator, right? I mean, those are ugly numbers, but let's let the calculator do the work, right? So, tell me when you're ready for me to do the calculator. Are you guys caught up yet? I'll let you catch up. And then I'm going to use my calculator, okay? Oh, you got it. Katie's way ahead of me, okay? All right, so clear. So, what is square root of 45 parentheses divided by the square root of 20? Like 1.5. Hey, same ratio as last time, right? So they've got to be equal. So the ratio is 3 over 2. 3 over 2 equals 3 over 2. So what am I going to say? They're similar by what? So yes, they're similar by what? Side angle, side similarity. Yeah, because we proved it. And the ratio is 3 over 2, right? Okay. Hang on to these. Don't lose these. It's going to really help. Now, there's some things that I did not put on the review sheet because I put it on the